we're going to run through the 1-3 notes real quick here. Today we're introducing really two formulas and a definition. So the first formula is the distance formula, and this leans back on our Pythagorean theorem. So if you think about having 2 points that are a certain distance apart, we're trying to find the length of this distance, which means we need this side, which is really how much x changes by. So the x2 minus the x1, and this side, which is the y2 minus y1, or how much the y changes by. So if I go back to my middle school geometry days and I set up Pythagorean theorem, I get x2 minus x1 squared plus y2 minus y1 squared, and that equals d squared. Leg squared plus leg squared equals hypotenuse squared. So for distance formula, what we do is we take the square root of both sides, and we end up with the distance between 2 points D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, this is the distance between the points x1 comma y1 and x2 comma y2. So that's our distance formula. Now, the midpoint formula, what it does is it tries to average the x's and the y's. All right, so when I look at 2 points, an x1 comma y1 and an x2 comma y2, all right, we want to find the middle y value and the middle x value. If we do that, we get the midpoint, which is the point that's directly in the middle. So if I have those 2 points, what we're going to do is we're literally going to average each of them. So we're going to take x1 plus x2 and divide that by 2 to get an average. And we're going to take y1 plus y2 and divide that by 2 to get an average. And that's actually our midpoint formula. So the midpoint, all right, it is a point, so we expect an ordered pair. It is given by x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. All right, and this gives us the midpoint between the points x1 comma y1 and x2 comma y2. All right, so that's our midpoint and our distance formula. So those two formulas are going to be super important as we continue through this section, and most of the problem sets will be using those. All right, so if I'm thinking about memorize or flashcard facts, those would be prime examples of flashcard facts. Now, moving on to segment bisector, that's any geometric object that cuts a segment exactly in half. So if I have segment AB, all right, I can have a segment bisector that's a line. So I could have something like this, line CD, and as long as it cuts AB perfectly in half at that intersection point, then it's considered a segment bisector. All right, so it could be a line, it could be a ray, any object that cuts a segment perfectly in half. All right, so any object that cuts a segment perfectly in half, or using fancier words, that cuts it into 2 congruent segments. All right, so cuts into 2 congruent segments. All right, so those are really the 3 words that are going to be at the heart of today's lesson. If I go to my first example, it says the coordinates on a number line, j and k are negative 12 and 16 respectively. It says find the coordinates of the midpoint. All right, so if I go j and k, all right, so j is at negative 12. All right, k is at 16. All right, so I only have one dimension, so I'm only using one aspect of the midpoint formula. All right, so on this, the midpoint, we're really only concerned about the x. So we're going to take the average of that, negative 12 plus 16 divided by 2. That's 4 over 2, which is 2. All right, and 2 is going to be the midpoint. It's kind of right here in the middle between the 2 values. All right, so the midpoint is 2. Now, if I push on to the next one, it says find the length of AC and the exact coordinates of its midpoint. All right, so we're going to do a distance formula for the length. So distance, we have d equals square root. We're going to take the two x's and subtract them. So 4 minus 1 squared. All right, using the x from this term and the x from this term. Plus, and then we're going to go the y. So the 0 minus 4, quantity squared. 4 minus 1 is 3. All right, so I have 3 squared plus 0 minus 4 is 4, negative. So negative 4 squared. 3 squared is 9. Negative 4 squared is 16. So I have square root of 25. All right, and square root of 25 is 5. So the distance is 5. All right, and then that's for the midpoint. So for midpoint, all right, we're going to take the average of the x's, so 1 plus 4 divided by 2. Average of the y's, 4 plus 0 divided by 2. All right, that's going to be a 5/2, comma 2. All right, and that would be our midpoint between those two lines. All right, so that's the first portion of the video. I'll be back on for the second portion.